Hello everyone, welcome to Gate Academy Global. So before starting today's session, I would like to have the input as well as the concurrence regarding the quality of video as well as audio. If it has been bang on, just write perfect over the live chat and then we are going to go ahead. The student who had been new in this session, they should have a clear cut idea that what had been going on since last 9 days. As you can see very well, the each and everything has been clearly written over here. Since last 9 days, we had been focusing over the important topics of the engineering mathematics, which had been important for all of the branches. Whether you have been from electronics, electrical, instrumentation, mechanical, production, computer science, IT, chemical. The important topics which we are going to cover over this session of live session. The first topic which we are going to cover is going to be probability. Approximately 30 to 40 hours we are going to spend in probability itself, because for the probability total 4 different important topics are being segregated. Among them, the first is being permutation and combination, then the questions related to the or word problem related to the probability, third is being stats, and the last is being random variable and random process. Agreed what I am saying? As the videos are supposed to come on our Gate Academy Global, that means my mode of communication is going to be purely in English. So obviously it would be fruitful for the student who are not been well acquainted with Hindi, or the student who are been from the southern part of our country, and even the student who are been from northern part of our country who are been more acquainted in English, then also you can easily grasp each and individual concepts which are being communicated over this lecture. As far as the timing is being concerned, precisely at 7:30 we are going to get live. And approximately the video lasts for 1 hour. So you can say the span of video is going to be somewhere in between 7:30 to 8:30. Yes. And I would request to each one of you, if you really wants to learn each and individual concepts of the mathematics, if you really wants to learn each and individual topics within the engineering mathematics, maintain the crowd over the live session. If 15 number of students have been sitting in live continuously, definitely I will start from the beginning and will cover the complete mathematics, which includes all of the topics, whether it's been the concept of probability, whether it's been the concept of calculus, whether it's been the concept of differential equation, numerical method, Laplace transformation, each and everything would be completely covered. Agreed? So let me straight away hop into the working mode. So the student who must have been attended my last class, they should have a clear cut idea what are the important concepts are being dealt in the last class. In last class I was discussing about the random experiment, an experiment whose outcome is being unpredictable. So whenever you had a problem related to the probability, by default an random experiment must have been connected with that problem, like tossing a coin and finding the probability of head, tossing a coin and finding the probability for getting tail, rolling a die and the probability for getting 1, rolling a die for getting a probability even, odd, prime. What I am saying, whenever the probability based questions has been arrived, whenever you had been dealing with the probability based question, by default random experiment is being the other part of question. There would always be a part of the question, random experiment, the experiment whose outcomes are being unpredictable outcome that we have already seen. The examples could be rolling a dice. If a die is being rolled, the outcome could be anything in between 1 to 6. Tossing a coin, if you toss a coin, the outcome could be anything head or tail. Tossing a coin. In last class we saw probability for the occurrence of a certain event E is being written as the P of E. Mathematically it's been defined as number of favorable event which favors your event E, number of favorable events divided by of total number of events in your sample space. Total number of events on your sample space, where the number of trial had been reaching towards infinity. That has been a very important point everybody should have a little bit idea of. Like if a coin is being tossed, Let's take infinite number of times the coin has been tossed. You'll see infinite divided by 2 times the head had come, and infinite divided by 2 times the tail had come. In virtual, we can say half times the head had come, half times the tail had come. In the same sequence, the next important point which we had seen in the last class, as far as the probability concept is being concerned, the probability word had come from possibility. As we had been dealing with random experiment, you exactly do not know whether the 1 is supposed to appear 2, 3, 4, 5, 6, but still you had a little bit idea that out of 6 number of trial, one time 1 is going to appear. So what it is been, 1 by 6 is being just merely a possibility that a die is going to be rolled. Approximately in each 6 trial you are going to get 1. So probability is nothing but certainty in uncertainty. Certainty in a uncertain experiment. We had always seen one more important thing in the last class. The experiment which you are conducting must be a fair experiment or unbiased experiment. So another important word which we had seen in the last class is been fair experiment, unbiased experiment. So if somebody says the probability for the appearance of 1 as a top face if a dice is been rolled is been 1 by 6. This result is been a true only and only if the occurrence of 1, 2, 3, 4, 5, 6 are all being equiprobable, then only the probability for the occurrence of 1 is going to be 1 by 6. I had taken an unfair event in the last class. If the experiment has been like this, the 6 has been the face of a die, and now rather taking a complete roll, I had taken a roll over the 4 faces. In that case, what is going to be the possibility or the probability for the occurrence of 6? That is going to be 1 by 4, because total number of events in I sample space is been 1, 2, 3, 4 faces, and out of that 4 faces, the 6 is been the 1 face. So whenever I say fair experiment, unbiased experiment, random experiment, many of the students used to scratch their brain. Otherwise, this has been a common most understanding of the problem. Did you understand what I am saying? I have seen many of the times in a random experiment, in a fair trial, in a equiprobable experiment, when this sort of words are being there in the part of your question, no, I had seen many of the students start shivering. They feel, sir, I exactly do not know what does it mean by the random experiment. I do not exactly know what does it mean by the fair experiment or unbiased experiment. So probably these 3 to 4 important terminologies which are been very important terminologies within the probability must have been clear to all of us. If I say a fair coin is being tossed once, what has been the probability for getting head? Obviously it's going to be 1 by 2. If a fair dice is been rolled, what has been the probability for getting 1? It is going to be 1 by 6. A fair dice is been rolled, what has been the probability for getting even number? So 2, 4 and 6 out of 1, 2, 3, 4, 5, 6 are been the even number. So towards numerator side we are going to add 3, and similarly towards denominator side we are going to add 6. Even they may ask, if a unbiased dice has been rolled, what has been the probability for getting prime number? So 2, 3 and 5 are being the prime number out of 6 different numbers. So the result is simply going to be 3 divided by 6. So do you have the clear cut idea why this important terminologies had been taught at very beginning? Because in my time, whenever in question fair experiment, unbiased experiment or random experiment had been the part of question, no, I used to shiver like anything, because I was not knowing the basic concept of the probability is been derived from this many important terminology. You can write something. The basic terminology of the probabilities are been derived from this important terminologies. Basic concept of the probability has been derived from this particular terminology, which includes random experiment where the outcome has to be randomized. Similarly, the experiment which we had conducted has to be fair experiment, otherwise we won't be able to tell anything. If die has been kept something like this, and let's take the 6 has been the part towards left or right side, and if it had been rolled, if I'll ask what has been the probability that the upper face has been 6, it is going to be 0, because 6 is not going to come at any cost. That is what I am saying. Whatever the calculation has been made, that had been made based on fair experiment or unbiased experiment. Agree? Now the next important point. infinite number of times. This has also been a big sir dard. Infinite number of times. The question can also get phrased. An experiment is being conducted infinite number of times, or infinitely large number of times, or very large number of times. Or let me phrase a question. If a die is been, or die has been rolled infinitely many large number of times, what is been the possibility for getting one in each trial? Now, as we know, as for the formula, if limit n has been tends to infinity, in that case, occurrence of, or the probability of a certain event is being defined as the number of events in your sample space, as favorable space, divided by the total number of events in your sample space. Total number of events in your sample space. Yes, I would like to ask from each one of you, could you had a little bit idea that which kind of the problem get phrased, and I do not have to worry about the random experiment, probability, fair experiment, or infinite number of times, because whatever the questions are being phrased, the number of experiment has to be made infinite number of times. Otherwise, what will happen? If you toss a coin, probably first trial, head is been experienced. Again, you had been tossed a coin, again head had been experienced. If you had tossed a coin, again head had been experienced. At the end of the day, you will say, sir, the possibility for the occurrence of head is been 100%, but the tail is been 0%. No, this is not the case. If you will keep repeating that experiment again and again, theoretically speaking, infinite number of times, you will see infinite divided by 2 number of times the head had appeared, and infinite number of 2 times the tail had appeared. Tail had appeared. Agreed? Similarly, next has been random experiment. Sometime it had been written in a random experiment of rolling a dice. Obviously, rolling a dice is been a random experiment because its outcome is been unpredictable, but you can't say it's being completely unpredictable. It would be anything in between 1, 2, 3, 4, 5 and 6. 5 and 6. So I think this has been a point where almost all students must be having a clear-cut thought idea. Yes. The next important point has been the sample space. Sample space. This has been again an important terminology which I will be using within this topic again and again. Sample space. I would be referring this as S within the curly bracket. S within the curly bracket. Why the curly bracket is being used? Because the sample space is going to be the collections of elements, or I would say it's been the sets. Yes. Collections of elements. So whenever I say the sample space, the meaning of the sample space is been all possible element from any random experiment are being collected in a form of sets is being called as a sample space. If you want, you can write. If you want, you can write. Sample space is been defined as collection of all possible events from a random experiment. From a random experiment. Let me take few number of examples. Rolling a dice. This has been a random experiment. The outcome could have been head or tail. In this case, if we'll talk about the sample space is been the collection of all possible outcomes from any of the random experiment. So obviously the random experiment is been a rolling a dice. So the possible outcome could be anything in between 1, 2, 3, 4, 5, 6. Where the 1, 2, 3, 4, 5, 6 is been the element and that had been consolidated in a form of set, which we had studied in the class 11, but it is not at all required to study the concept of probability. In the same sequence, let me take another random experiment. Rather rolling a die, now we had been tossing a coin. Again, the sample space is going to get referred by capital S. And all possible events which are being encapsulated in a form of sets are being called as a sample space. So the possible outcome could have been anything in between head and tail. Let me take another example. Rather tossing one coin, two coins are being tossed together. Two coins are tossed. If two coins are being tossed together. Yes. Two coins are being tossed together. So what are the different possibilities you had, my dear friends? Let's take this has been the first toss and this has been the second toss. The first toss could have had. And if the first toss could have been had, we had fixed the first toss, outcome has been had. The possibility for the second toss could have been had as well as tail. So as far as the head is being concerned, the two T branches are being taken out. Two T branches are being taken out. Now we take another scenario. The first trial had been received as a tail. Again, we had got a two branch over this tree. Tail over head, tail over tail, tail over tail. So how many different possibilities we had? Total 4 number of different possibilities we had. So if you want to write the total number of events, if the two coins are being tossed together, it could have been head head, head tail, tail head, tail tail. In total, the 4 different events we had, and it would be written under a small box. And here comes head tail, tail head, and here comes tail tail. Here comes tail tail. Here comes tail tail. How many different possibilities we had? Obviously, 4 number of different possibilities we had. If we talk about the number of elements in your sample space, which has been written as n of s, how many total number of events we had? 6 number of total events we had. For this particular random experiment, if we'll talk about the size of sample space or number of elements in sample space, how many total events or total elements we had? 2 number of total elements we had. But here if we'll talk about the number of elements in my sample space or the size of sample space, it is going to be the first element, second element, third element and fourth element. Total 4 number of elements we are going to have. Agreed? If I take another question, two coins are being tossed. Now we had been taking the two dice are being rolled, together, rolled. May I know what would be the size of the sample space? Because I have seen many of the students used to do the silly mistake at this moment of point. See, in first trial, the outcome could have been anything in between 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 5 and 6. Yes. And as far as their branches are being concerned, the subsidiary or upcoming outcome could have been anything in between 1, 2, 3, 4, 5, 6. Obviously, it starts from 1, 2, 3, 4, 5, 6. Here, the first outcome has been 1, second outcome has been 1. First outcome has been 1, the second outcome has been 2. 1, 3, 1, 4, 1, 6, so on and so forth. So, may I know how many total number of branches we had in this tree when the first outcome has been 1? Obviously 6. It had been 1, 1, 1, 2, 1, 3, so on and so forth. Same goes with 2 as well as 3 as well as 4 as well. 4 also would have the same segmentation. It can get connected with a 2, 3, 4, 5 and here comes 6. And that has been 4, 1, 4, 2 and here comes 4, 6, 4, 6. Yes. How many total ways we can arrange this? Total 36 different ways we can arrange this. Yes. So if I'll talk about the number or the size of the sample space or the number of elements in my sample space is going to be 36. What is going to be the structure of it? Obviously the sample space has been a type of set, would be kept inside a curly bracket. The first event could be 1, 1. Second event could be 1, 2, 2, 3. And the last event in this first row could have been 1, 6. Similarly, this could have gone to 2, 1 and then 2, 6, 3, 1 and then 3, 6. Last one has been 6, 1 and 6, 6. 6, 6. So as far as this sets is being concerned, how many total number of elements we had? 36 number of elements we had. Elements we had. Agreed? 36 number of different elements we had. In the same sequence, let me move forward. Tell me if 3 coins are tossed together. together, what is going to be the size of the sample space? This has been my first question. If one coin and one die is rolled together, what is going to be the size of the sample space? If 3 dies are rolled together, what would be the size of the sample space? What would be the size of the sample space? So you could have seen one thing, merely multiplication is going to take place. Total possibilities in first trial were 6. Total possibilities in second trial are been 6. Rather getting addition, we had just been multiplied, and that is what happens in case of branch splitation. And here the branch has been made. Either you can make a combination of 1 1 1 2 till 1 6, and similarly 6 1 6 2 till 6 6. Total 6 number of branches were there in the first, second, third, fourth, and sixth. Put together 36 number of branches we had. In totality, I can say the size of the sample space is going to be 36, or the number of elements within the sample space have been 36. Merely multiplication had been taken place. If you will take the example of this random experiment as well, the total 2 possibilities we had in first trial, total 2 possibilities we had in second trial, just multiplication had been taken place. I had seen many of the times the student do mistake. What they do, they used to try to add them together. Here addition and multiplication results the same value, but here if you will take the addition, 6 plus 6 becomes 12, whereas the multiplication becomes 36. So keep in mind, always the multiplication takes place. Multiplication takes place. So the same way happens over here as well. 3 coins are being tossed together. In first coin, the total possibilities were 2. In second coin also the total possibility were 2. Put together, the result is being 8. If you want, I can write it over here. See, just focus. How do we write a digital system? 0 0 0 0 1 0. So 0 is being taken as tail and 1 is being taken as head. So here 0 0 0 0 0 1 0 1 0 0 1 1 1 0 0 1 0 1 1 1 0 1 1 and 1. How many total events we had? You can see 4 plus 4, 8 number of events we had. 8 number of events we had. Midun, as for the Midun, 1 coin and 1 die. Obviously Midun, you have been perfectly correct. As far as 1 coin is being concerned, the total number of possible outcomes are being 2. 1 die is being rolled. What is been its possible outcome? 6. Multiplication is going to take place, and the result is going to be 12 different ways this could have done. 12 different ways this could have done. 3 dice are been rolled together. Number of possible outcome in first roll is been 6, in second roll is been 6, in third roll is been 6. Put together, the result is been 6 to the power of 3. 6 to the power of 3. So I feel from here onwards, if you had been dealing with a complex experiment or the complex trial where 1, 2 or 3 number of different experiments are being conducted or connected with the same experiment, there you should have a clear cut idea how many different number of elements are being there as a part of sample space, are being the part of sample space. Yes, so this is must also be clear to all of us. Now the next thing, this has already been seen. If we talk about the probability for the occurrence of a certain event E, mathematically it is been written as a P of E, and P of E is been defined as the number of favorable event or the number of events which favors your event E, for which the probability is to be calculated, divided by the total number of events in your sample space, size of your sample space, or the number of elements in your sample space. So the P of E has been defined as favorable number of events, favorable number of events, favorable number of events divided by total number of events in your sample space. Total number of events in your sample space. Let's take the favorable number of events is being taken as M, and the total number of events in sample space is being taken as N. The next important thing, you can see very well, the favorable events Let's take it is being taken as E. Even this is also going to be a set. How? If a die has been rolled and you had been looking for the probability for the occurrence of an even number. So may I know what are the different events would be a favorable event? It would be 2, 4 and 6, or I should say the sets of 3 numbers 2, 4 and 6 are being my favorable event. So the collection selection again makes a set. So favorable event would again make a set, and that is why rather writing it small, I would write this as E. This as E. It has been my favorable set. Favorable set. Set. Yes, it is going to be my favorable set. So in totality, I can say probability for the occurrence of my favorable event E is equals to of number of event, favorable number of event. Favorable number of event or the favorable event itself is being again a set. So I can simply call the number of elements in my favorable event N of E divided by the number of events in my sample space. Sample space. You can see very well. You can see very well. Agreed? So the probability for the occurrence of a certain event E, P of E could have been written as N of E divided by N of S. What had been the N of E? N of E is been the number of elements in my favorable event. Number of elements in my favorable events, and N of S is been number of elements in my sample space. And keep in mind this formula would remain true only and only if the number of trial is been infinity, the type of experiment is been fair in nature. So what I am saying, the basic concept, basic methodology which we had discussed in the last class and the first half of the today's class remained very same. There would not be any change. Agreed what I am saying? There would not be any change. Let me take few number of questions, and with the help of those questions we will try to connect almost all concepts which we had studied again. A fair coin, not coin actually, dice is been rolled. Find the probability. The outcome is even. Outcome is even. So here it starts solution. Nobody should get threatened by watching this word fair die. Anyways, it had been clearly said whatever the experiment you had been conducting has to be unbiased or fair in nature. Then only the formula which you had reduced, the number of favorable event divided by the total number of events in my sample space is going to work fine. Otherwise, the 6 has been there towards left hand side and right hand side, and if you say the possibility for offering 6 is been 1 by 6, no my dear friend, it has been simply 0. If the 6 has been kept somewhere here and if the roll is been made like this, which has been unfair, which has been biased, in that case if we will talk about the occurrence of 6, so obviously it is going to be 1 by 4. It is going to be 1 by 4. So that is what I am saying. This terminologies are being attached with many of the questions, and I had seen the student starts seeking. But no, the complete concept of the probability is been based on the concept of fair dice. Even they could have written this problem as a unbiased dice is being rolled. Obviously, that is also been a okay one. How do we do so? At very beginning, we focus over the event, which we call it favorable event. Favorable event. It's been a type of set. So obviously, the curly braces is going to be used. May you know what is going to be a favorable event? The favorable event is nothing but offering as or offered as event. So out of 6 different outcome, which includes 1, 2, 3, 4, 5, 6, 2, 4 and 6 are being your favorable outcome. If we talk about the S, which stands for sample space. Sample space. It's been a type of set, would be taken under the curly braces. May you know what are the different possible outcome with this random experiment? There had been 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. and at last we had been looking for the possibility or the probability for the occurrence of my favorable event P of E, and this has been defined as number of element associated with set E, number of element which are been associated with your sample space. N of E, how many total number of elements are been there part of this set N of E, that is been 3. How many total number of elements are been part of this sample space, is been 6. So the result is simply been 3 divided by 6, and that is been 1 divided by 2. That is been 1 divided by 2. That is been 1 divided by 2. Deliberately I am going into the detailed analysis, because when the experiment would become complex, how we can make a complex experiment, a die is being rolled, a coin is being tossed, and what has been the possibility, then in first die the outcome has been 1, and in second coin the outcome has been had. So we can make a much complex analysis. That is why we had been moving part by part, step by step, so that in future if you had been dealing with any kind of big sort questions, you will not have any problem at all. You will not have any problem at all. Is that part clear to all of us? I don't find any of the students would have any kind of doubt now. Two dice are rolled together. Two dice are rolled together. Find the probability. Both faces are same. Both faces are same. May I know what would be the possibility? What would be the possibility? No, dear engineer Pradeep Tiwari. Probably we are going to cover in English only. So I would request to you as well. Try to cope up with our English. Definitely after 1 to 2 number of lectures, you are going to get acquainted with my English as well as my way of teaching, and end of the day, you are going to enjoy my teaching and the engineering mathematics as well. And the engineering mathematics as well. Yes. Rather writing each and individual events or the element in my sample space, let me straight away hop into the number of elements which are been associated my sample space. May I know how many total number of events we had over my sample space. Two dice are been rolled together. We had seen in first dice the number of outcomes or the possible number of outcomes are been 6. In second roll the total possible number of outcomes are been 6. They gets multiplied. Obviously the size of my sample space is been 36. As far as the favorable event is been concerned, that had been written as E. It had been clearly written all of the events out of 36 number of events, where the first trial and the second trial leads the same number, is going to be my favorable number. So may I know what are the different events would be my favorable events? 1 1 goes with 2 2, 3 3, 4 4, 5 5, 6 6. This many number of events are been my favorable event. This many number of events are been my favorable event. If we talk about the probability of my favorable event E, I had to count the number of elements in my set E, or the number of outcome in my favorable event divided by the total number of outcome in my sample space. Total number of outcome in my sample space were 36 and total number of favorable events were 6. 6 divided by 36. The result is being simply 1 by 6. Simply 1 by 6. I would like to join your academy. The way of teaching is excellent. So I would request one thing, engineer Pradeep. Whether you had been preparing for GATE, PSU or EAC. If you had a clear-cut idea, no, at least try to ping me on this Telegram group. I can guide you each and everything. So my Telegram group is been. आप वो भी डाल देंगे अगर कुछ है तो अपने पास है. हाँ मैं कर रहा हूँ. So here it is been t.me abcd 1 2 3 df or straight away make a call on this Telegram. Once you go there, Sonal sir has been completely written over there. You just push a call button. I'll just be receiving your as well. Agreed? Yeah. So here it becomes 1 upon 6. Here it becomes 1 upon 6. Few more important terminologies which are being associated with the probability had to be explored yet. Few more important terminologies. Few more important terminologies. Few more important terminologies. So far, the important terminologies which are being discussed, let me list it down. The first has been the random experiment, the experiment whose outcome is being unpredictable. But you can't say that your outcome would be such an intense unpredictable that you won't be able to say anything. No, my dear friend. If a die is rolled, obviously the outcome could be anything in between 1 to 6. Outcome is been predictable. It could be anything between 1 to 6. But precisely you won't be able to say whether it would be 1, 2, 3, 4, 5 and 6. And that is why those sort of experiments are told as a random experiment. The second is being the type of experiment which we take for the reference is being fair or unbiased experiment. Unbiased experiment. We had seen this sort of problem from since class 9th onwards. If a die is rolled, what has been the probability for getting 1? It's been 1 by 6. For 2, it's been 1 by 6. For 6, 1 by 6. But the basic crux is been coming from fair or unbiased experiment. If either of the phase is been biased, or if either of the phase is not supposed to come at any cost, in that case, your outcome or the possibility won't be 1 by 6. Like we had taken an example, if 6 has been somewhere here at upper side, if the roll is been made like this, left and right faces are just going to get rolled towards left and right. They are not going to come as a part of top face. So may I know what would be the possibility for the occurrence of 6? It would remain just 1 by 4. Just 1 by 4. And let's take the left and right faces are been 2 and 4. So if I say what has been the possibility for the occurrence of 2, it has been simply 0. What has been the possibility for the occurrence of 4? That is being 0. So may I know which event is going to be the event which you can use over your probability, this event or this event? Obviously this event, because this event is being a fair event or unbiased event. So one thing must be there in your mind, which any kind of the probability questions which are being faced, they are being faced on the concept of fair or unbiased experiment. If it had been written somewhere in your question, you need not to get threatened. Like, sir, no sir, in my question unbiased experiment or unbiased events were written, so I could not approach that problem, my dear friend. The complete concept of the probability itself is been based on random experiment and fair and unbiased experiment. Unbiased experiment. Here comes the sample space. Sample space. The collection of all possible events are being called as a sample space. If a die is rolled 1, 2, 3, 4, 5, 6. Let's take 1, 2, 3, 4, 5, 6 are being taken as the elements of a set. So this complete sets is going to be called of a what? Sample space. Similarly, a coin is tossed, head comma tail. 2 coins are being tossed, head head, head tail, tail head, tail tail. They all are being the possible outcome which we can have over this random experiment. So I can say the collection of all possible events are being said to be sample space. Here comes the favorable event. Favorable event. Favorable events. Depending on the different problem, the favorable event or the structure of the favorable events are going to change. If one person might be looking 1 in a die of roll, the second person might be looking for even number, while a roll of die. Put together, the outcomes are been different. If the first person has been looking for 1, so in this set only and only 1 element we had. The second person has been looking for even number, so obviously it could have been the collection of 2, 4 and 6, anything. Yes, so that is what has been happening. Yes. Subhangi, we will take each and everything. We will take each and everything, but I would request to each one of you, try to motivate your juniors, your classmates, your seniors. If you really find this videos or the series of videos fruitful, this has been your responsibility. From my side, I had been putting the complete effort. Even the questions which I had been taking in the class, I had been posting its PDF on our Telegram group. So this much effort we had been putting, this much effort Great Academy had been putting. So now it is been your responsibility that you guys must propagate this quality to rest of the people. Agreed what I am saying? So I don't find till this point each and everything to have any kind of doubt. Now from here onwards, we had been bifurcating the type of events. events. And this has been a very, very crucial point, because I had seen, if you really understand which kind of the events you had been dealing with, using the formulas, using the axioms becomes very, very easy. And if you are mispredict, or you could not predict which kind of the events you had been dealing with, in that case what happens, you use the wrong axioms and end of the day you results a wrong answer. End of the day you results a wrong answer. So that is what I am saying, we had come to a very crucial point of a probability, where we are going to identify which kind of events we had been dealing with. Which kind of the events we had been dealing with. Write it down, it's been a very, very important point. So various kind of the events which we are going to write. The first is going to be exclusive event. Exclusive event. Name itself has been self-explanatory. What does that mean by the exclusive event? You must have heard, this has been an exclusive watch, this has been an exclusive bike, this has been an exclusive jewelry. What does that mean of it? Probably the company is just going to produce one or two number of goods. That's all. That is what the exclusive event talks about. If somebody says, sir, this has been an exclusive event, if this event is being taken place, the second event cannot take place. If the second event had taken place, the first event cannot take place. Like if I had rolled a die, events are being listed out. Let's take the events are being even numbers, odd numbers, prime numbers. May I know even numbers and odd numbers whether they had been a type of exclusive event or not? Yes. If one event takes place by default, you can't have the second event to be taken place. Second event to be taken place. Agreed what I am saying? So write it down, the exclusive event. Occurrence of one event. Occurrence of one event. One event restricts occurrence of other events. So if you had phrased the event, let's take the events are been 1, 2 and 3 and 4. If occurrence of one event restricts the occurrence of remaining events, in that case those all events would be called of the exclusive event together. Exclusive event together. Exclusive event together. Let me take an example. A dice roll. And let's take 3 to 4 different events are being manufactured. Here comes the first event, the second event, third event, fourth event. The event 1 is being the event for getting even numbers. Even numbers. E2 is being the event for odd numbers. Odd numbers. E3 is being the event for greater than 4. E4 is being prime number. Prime number. Let's take the fifth event is being number lesser than 3. Lesser than 3. So if we talk about the first event, may I know what are the different elements are being the part of this? Even number. All even number from 1 to 6. That is being 2, 4 and 6. All odd numbers. They had been 1, 3, 5. All of the numbers which are been greater than 4, obviously it's been 5 and 6. It's been 5 and 6. The number which is been prime, keep in mind the 1 is not been a prime number. So it starts from 2 and then you will be having 3 and then you will be having 5. Then you will be having 5 and the last is been lesser than 3. Obviously 3 would not be included. That is going to be 1 and 2. 1 and 2. 1 and 2. I would like to ask from each one of you, in between E1, E2, E3, E4 and E5, which are the events are being the type of exclusive event? Exclusive event says the occurrence of one event restricts the occurrence of other event. See, if the event is being occurred by default, it can't be odd at any cost. So obviously E1 and E2 are being a type of mutually exclusive event. How do we know that they had been mutually exclusive event? Virtually we can see, if the event takes place, odd cannot take place. If the odd is being taken place, even cannot be taken place. The another method is being their elements. You can see very well, there had not been any single element which has been common in both of the events. So I can say there would not be any common element between both of the events. You can see 2, 4 and 6, 1, 3 and 5. There had not been any common element between these two events. You can write somewhere. There had not been any common event between these two events. There had not been any common events between these two events. Similarly, if we'll say E1 and E3, E1 and E3. Yes, E1 and E3 is not been the part of mutually exclusive event. Why? I can't say if the E1 had occurred, E2, E3 cannot occur, or if the E3 had occurred, E1 cannot occur. You can see very well, because the 6 is been a common element in both. No sir, it is not been a mutually exclusive event. If I say E1 and E4, 2 is been common, again it can't be a mutually exclusive event. And if I say E1 and E5, no sir, it had not been a mutually exclusive event. It had not been a mutually exclusive event. Yes, but if I take E3 and E5, again they had been mutually exclusive event. E3 has been the event where the number after rolling a die is being greater than 4. So obviously the consolidation has been the consolidation of 5 and 6, and here it's been an event where the outcome has been lesser than 3, that includes 1 and 2. So if E3 occurs, E5 cannot occur. If E5 occurs, E3 cannot occur. E3 cannot occur. CP107, the test is going to get conducted on 3rd of July. There had been a certain issue because so many students wanted to enroll, and because as we had the same test has been catered to all of the branches, that is why the managing part had become a bit difficult, and that is why it has been postponed. 3rd of July. 3rd of July. Yes, 3rd of July. So again I can say E3 and E5 are being the mutually exclusive event. Would like to know from each one of you whether the concept behind the mutually exclusive event is even clear to all of us. What does that mean by the mutually exclusive? The mutually exclusive event, this word had come from mutual exclusion. If one event had occurred, the remaining event had been excluded. If the second event is been occurred, the remaining events is been included. Let's take, for the time being, you had made a 2 event. If E1 had occurred, by default you had ruled out E2. If the E2 had occurred, by default you had ruled out E1. Similarly, the same thing goes with E3 and E5. If E3 had occurred, by default that cannot be E5. If event 5 had occurred, obviously it could not be E3. It could not be E3. It could not be E3. So this part must be clear to all of us. This part must be clear to all of us. Now I would like to ask from each one of you, here comes the next event, or you can write this with a Venn diagram. Let's take this has been a sample space. It had been clearly seen that the favorable events which you had been bringing out, no, it would always be a subset of a sample space. You can see very well. If a die is been rolled, what are the different possibilities we had? 1, 2, 3, 4, 5, 6. The different favorite event which you had been manufactured, what are they? They are been 2, 4, 6, 1, 3, 5, 5, 6, 2, 3, 5, 1, 2. What are they? They are been the subset of your sample space only. So one thing has been quite sure. In practicality, you will see any kind of favorable event which you had been picked out from the sample space would always be the subset of the sample space. You can see very well 2, 4, 6 has been the subset of 1, 2, 3, 4, 5, 6. 1, 3, 5 has been the subset of 1, 2, 3, 4, 5, 6. 5, 6 has been the subset of 1, 2, 3, 4, 5, 6. 2, 3, 5 has been the subset of 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Yes? Yes, no? So this part must be clear to all of us. So we had taken the 2 event. These 2 events are said to be mutually exclusive event if they do not carry any common event, or I would say they do not have any of the common area. So I can take this as E1 and I can take this as E2. E1 contains 2, 4, 6 and E2 contains 1, 3, 5. You can see very well. You can see very well that they do not carry any of the common element. They do not carry any of the common area. So I can say their common areas are being 0. Whenever we had been dealing with mutually exclusive event, and when you show with the help of Venn diagram, their common area is going to be 0. Their common area is going to be 0. Their common area is going to be 0. Common area is going to be 0. Yes. Till this point, I don't find any of the student would have any kind of doubt now. Okay. Now in the same sequence, the next kind of the event which we have been focusing on has been the dependent event. The name itself has been self-explanatory. The events are being dependent or must be sharing few common elements. Dependent events. In short, I can say the events are said to be dependent if they share at least one common element. Events are said to be dependent event if it shares at least one common element. Let me take this outcome. This 5 different favorable event is being manufactured. Now let me take the reference of those. Mutually exclusive event is already been discussed earlier. Let me focus over the dependent event. The events which contains at least one common element. E1 and E2? No sir, I do not have any of the common element between E1 and E2. No, it can't be dependent event. But if I take the reference of E1 and E3, you yourself would be able to see the 6 is been a common element in both of them. So E1 and E3 would come under dependent event. Not only that, even if you take the reference of E1 and E4, you must be able to see 2 is been a common event in both of the cases. So I would say E1 and E4 had also been a part of dependent event. Yes. In terms of Venn diagram, if I would like to learn something, this has been my sample space. It had been clearly seen that the favorable events are going to be the subset of your sample space. Let's take this has been your first favorable event. It's been taken as E1. And let's take this has been your second favorable event. It had been taken as E3. So far, we did not have any common area. We did not have any common element, but now we had a common area as well as a common element. Anyways, the common element indicates the common area actually. E1 contains 2, 4 and 6. E3 contains 5 and 6, and the 6 is being contained in E1 and E3 together, E1 and E3 together, agreed? So if you want, you can write so many events are being a type of dependent event. If you will take the reference of E4 and E5, again it's been a dependent event. So we'll do one thing. This many important terminologies are being discussed in today's class. Taking the help of this many important terminologies, we will go ahead taking few number of questions in tomorrow's class. You should have a clear-cut idea. Random experiment had been discussed in the great detail. The possibility or the probability for the occurrence of a certain event is being called as P of E. The probability is been defined as the certainty in a certain uncertain event. Like if a die is been rolled, although you do not exactly know whether the 1, 2, 3, 4, 5 or 6 is supposed to come, but at least you know one thing, that out of 6 number of trial, one time 1 is supposed to come. As far as the type of experiment is been concerned, all kind of the experiment which we had taken for the sake of problem framing, they were fair experiment or the unbiased experiment. If your experiment is not been a fair or biased, in that case what is going to happen, the outcome would be something spurious or misleading. At the same time, it has already been taken, the probability is been defined if the number of experiment is been conducted in infinite number of time, because if you must have been tossing a coin, first time the head had appeared, second time head had appeared, third time head had appeared, and you will start scratching your head, sir. The possibility for the occurrence of head is been in 100% and possibility for the occurrence of tail is been 0%, but this is not the case. If you will be keep repeating the same experiment again and again, you will see n divided by 2 times the head is supposed to appear, n divided by 2 times the tail is supposed to appear. Now a few more important terminologies are being introduced in the today's class. It's been the sample space. The sample space is been the collection of all possible events. If a die is been rolled, obviously 1, 2, 3, 4, 5, 6 in a form of set is going to be a sample space. If a coin has been tossed, head comma tail, again it's been consolidated in a form of sample space, or is being a consolidated in a form of set, is again been a sample space. If two coins are being tossed, so here comes head tail, head tail tail. Total four possibilities we had within your sample space. Within your sample space. There also a few number of examples are being taken. Rolling a dice, 6 number of elements we had within a sample space. Tossing a coin, 2 number. Tossing 2 coins has been 4 number, and similarly rolling 2 dice are been 36. So the virtual impact which I wanted to brought out of it has been the multiplication. Whenever the two independent events are being taken place, and if you wants to club them together and wants to face a simple sample space, in that case their outcome gets multiplied. Their outcome gets multiplied. Same like this, 3 coins are being tossed together, there the 2, 2 and 2 gets multiplied thrice, put together the result has been 8. Amusing question I had designed. Even you can have a problem where once the coin has been tossed and once the die has been rolled, so the outcome could have been 1 gates with head and tail, 2 gates with the head and tail. So in each and individual number the 2 branches are being made, put together 12 different numbers or the possibilities are being made. Yes. In the same sequence, the probability for the occurrence of a certain event P of E is been defined as a number of favorable event in my sample space divided by the total number of events in my sample space, which had been written as M by N. But in logical way, the P of E has been written as the number of elements in my set E, number of elements in my set S, or I would say the size of sample space, size of favorable event. Now, a question is being taken. The question says a fair die is been rolled. Find the probability that the outcome is been even. If a favorable event or if a fair die is been rolled, may I know what are the different possibilities you had? Because all outcomes or all possibilities together would frame a sample space. So obviously, sir, it had been 1, 2, 3, 4, 5, 6. So you focus over the size of the sample space, which has been 6, and similarly size of your favorable event, that has been 3. Put together the result which we have been finding over here, it's been 3 divided by 6. Result has been 1 divided by 2. Result has been 1 divided by 2. 2 dice are been rolled together, probability both our faces are been same. Anyways, forget about the each and individual calculation, just focus over the N of S, N of E. N of E is going to be 6. It could be 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. And similarly, the number of elements in my sample space has been 36. 1 gets connected with a 6, 2 gets connected with a 6, 3 gets connected with a 6. In totality, we are going to have 36 different outcomes. So the result has been 36. At denominator and 6 has been towards numerator, the result has been 1 upon 6. One thing could have been seen. The event which you had known would always be the subset of sample space, like total 36 number of events we had. Out of 36 number of events, my favorable event is been merely 6. Here also, out of total 6 number of outcome, or out of total 6 number of elements, the 3 number of elements are been my favorable event. So I can say this 2, 4, 6 has been the subset of 1, 2, 3, 4, 5, 6, and similarly 1, 1, 2, 2 has been the subset of 1, 1, 1, 2, 1, 3, so on and so forth. Same goes here as well. So the important terminologies which we had discussed has been the random experiment. The type of experiment with which we had been dealing with the probability has been the random experiment. The type of experiment has been the fair or unbiased experiment. Otherwise, the possibility for the occurrence of 1 in a rolling a die would not be 1 by 6. Sample space, the collection of all events. The favorable event is going to be the subset of your sample space. Now the type of events are been very, very important, as it had been told, because until and unless you are not able to assess which kind of the events which we had been dealing with, you won't be use the proper axiomatic formulas, and if you will be using the improper or wrong axiomatic formula, the result would be wrong, and if it's been a problem of MCQ, you will land up with negative marks as well. So the first kind of the event is been the exclusive event. The name itself has been quite understandable. Occurrence of one event excludes the occurrence of remaining events. Like if a die is been rolled, by taking the reference of the outcome from a die, the 5 different events are been made. May you know among them which have been the events are been the mutually exclusive events. I would say there should not be any common element. So you can see very well E1 and E2. If the odd had come, even can't come. If even had come, odd cannot come. Even cannot come. So yes, the E1 and E3 is been, E1 and E2 is been mutually exclusive event, and E3 and E5 is been the mutually exclusive event. Mutually exclusive event. In the same sequence, if we talk about the dependent event, What does that mean by the dependent event? So the sort of event which we had been dealing with, which contains at least one common element. So the 5 number of events which we have already taken, let me take a analysis of it. The even number, odd number, greater than 4, prime number, and no lesser than 3. If we'll take the reference of E1 and E2, one thing has been quite sure, there had not been any common element. So obviously E1 and E2 cannot come under the dependent event. But if I take the reference of E1 and E3, obviously they had been the dependent event. How did I know about it? Because 6 has been a common one. 6 has been a common one. Yes. So this is all about today's class. If you guys are having any kind of doubt, if you guys are wants to give a certain sort of feedback, you can give it to me, and then we will meet precisely at same time tomorrow, and that is been from 7:30 to 8:30. 7:30 to 8:30. Tell me. Yes. If you guys are having any kind of doubt, you can ask over here. And one more important thing, the student who had not purchased or any of the product, I would request to each one of you, if you have been more acquainted in English, the complete course in a form of PD, GD, VOD, tablet is been readily available. You can just hop on in our website, just write gateacademy.com. gateacademy.com, each and everything or each and individual product would be clearly visible in front of you. Agreed what I'm saying? And even we had been offering those all quality courses with huge discount. Even the 3 number of lectures or the 3 number of subjects are being taken by me. 2 number of subjects, among them the control is being completely taught by me. Analog is being completely taught by me, and even the mathematics shooting is already been started. Yes. Thank you. Thanks, dear. Midun, may I know exactly from which particular state you have been? Are you from Kerala or what? Tell me, Midun. So at least I should have a clear-cut idea. The student who had been following our Gate Academy Global belongs from which are been the different parts of our country. Gautam Das, may I know exactly from which particular state you had been from? Subhangi, you are from which particular state? Kerala, yeah. My guess was correct. Kerala. Gautam, you are from? So try to have a contact with me, and any kind of doubt, technical, non-technical, you can just ask those questions over my Telegram group. And as you guys are been continuously attending my lectures, this has been my responsibility that definitely I will talk about your doubts or any kind of hindrance you had over the live class. Himachal Pradesh, Subhangi, great. Vijay, Gautam, that's great. So precisely at 7:30 we are going to meet with the same agenda, where we would be focusing over the next part of the probability. We will take few more number of important terminology and then straight away hop into the axiomatic approach and the important questions based on the concept of probability. So this is all for the today's class. We will meet tomorrow precisely at same time with the same enthusiasm, with the same agenda. Till then, bye bye, take care.